Welcome to Oceanside Chat, Light Beyond Generations. This podcast was created to inspire, motivate, and provide insight through industry professionals sharing personal stories, career aspirations, and practical advice. Our guest, Francisco Buitron, is a senior operation and supply chain executive in the semiconductor industry and has advanced supply-demand planning experience for over 30 years. Time to get your feet wet in the business world and join us down by the water as we have an Oceanside Chat. Season 2, Episode 3, The Art and Science of Capacity Planning. Welcome to Oceanside Chat. I'm Helen Wang, the host and editor of the program. Let me start by thanking our live audience of students, faculty, industry professionals, as well as listeners who followed our podcast around the world. Despite the constant dynamics between supply and demand, capacity planning is a long-term decision that establishes a company's overall resources. The design capacity is the maximum amount of work that a business can complete in a given period of time. In other words, collective investment in all supply chain nodes could only create a finite capacity. Furthermore, capacity decisions affect the production lead time, customer responsiveness, operating cost, and ultimately companies' ability to compete. The question of when capacity should be increased or decreased, and by how much, are critical decisions. In particular, inadequate capacity can lead to the loss of revenue, and excess capacity can drain the company's resources. Failure to make these decisions timely and correctly can be especially damaging to a business's overall performance. For this episode, I invited a special guest to discuss the crucial topic of capacity planning at the micro level. But because of his in-depth knowledge and over 30 years of experience in the semiconductor industry, we hope to understand the challenges and best practices universally applicable to others. Let's welcome Francisco Buitron, a senior executive in supply chain and operations for leading semiconductor companies such as Infineon, Skyworks Solutions, and currently Qualcomm Technologies. Francisco, welcome.
Thank you, Helen, and thanks everyone for joining. It's a privilege to be here, and hopefully I can share some of my experiences and knowledge and answer some of the questions from the audience as well.
Awesome. UC San Diego. We're located in the beautiful La Jolla, a seaside neighborhood with Qualcomm's headquarters within San Diego, California. Many people would say it's the best place to live on the earth. But Francisco, if you have to make a choice, would you rather live in the ocean or on the moon?
Ocean, for sure.
Why is that?
I don't need to live in the moon. I don't know how it is over there, but definitely I like the ocean, the weather. Yeah, I like outdoors. So
yeah,
I would say that.
Wonderful. Could you tell us a little bit about where you originally come from and your hometown?
Yes, I was born and raised in Mexico City. I went to school there. I studied industrial engineering and systems from one of the best schools, the private schools at Tecnológico de Monterrey. Once I finished, I knew I wanted to join the maquiladora boom that was happening in Tijuana, where all the large companies in Japan, Europe, and the US were doing a lot of the assembly and basically moving their manufacturing to take advantage of the labor pool and the lower cost. So there was a lot of work for industrial engineers at that time, and that's where I started. After a few companies, I was lucky enough to land a job at International Rectifier, which later became Infineon, and started working there in manufacturing. And that's where my semiconductor experience started more than 30 years ago.
Wow, so you're saying 30 years ago, Mexico is already taking on semiconductor manufacturing.
Back then, I would say it was more of an electronic assembly. It was the largest manufacturer of TVs back then. A lot of the big panel plasma TVs started later on. So it started with electronic, but later on, a lot of companies moved their assembly and test operations to Mexico. either in the border or in Guadalajara. And you see a lot of manufacturing electronic companies doing assembly for semiconductors or some level of semiconductor support.
What is one thing that we don't know about your hometown that you would love everyone to know?
Well, everybody probably knows that we have a lot of good food and very good tequila, but maybe a lot of people don't know that we have a beautiful wine country just 100 miles out of San Diego. So it's called the Valle de Guadalupe, and we have a large production of wine, but it's for domestic production mainly. So not a lot of people this side of the border or even in Europe know that Mexico produces really good wine. It's growing and it's a great industry. So that's probably one thing most people don't know.
That's fantastic. Thanks for sharing that. As a child, Francisco, what did you want to be when you grew up?
That's a good question. So I wanted to be an architect like my dad. So I used to be in construction sites with him, designing homes, visiting different companies since I was little. So I really wanted to be an architect, but my dad convinced me not to. He said, that's very tough and it's hard to get a job. Why don't you go into supply chain, industrial engineering? That is the future. You know, every company, no matter what industry, you need supply chain professionals. So that combined with a teacher early in my career also explained the supply chain. I just fell in love with it and I said, I'm going to do industrial engineering. And yeah, I've been doing supply chain since then. Yeah.
Wow, impressive. What are some of the facts about your life now would most impress your 5-year-old self?
You know, I work in several countries, so I think that has helped me shape the way I approach working with teams from multiple cultures, different countries. So I think the semiconductor industry has allowed me to travel the world. I work in different countries in Europe, within the US, and also in Mexico. And I just love the globalization of the industry. And pretty much these days, every industry uses more and more semiconductors. I think that's one thing that has helped me a lot to grow as a person and also enjoy this.
So it's a beautiful story that your dad actually advised you go to supply chain, working something easier than architect, right? What do you think about that decision that you actually joined maybe one of the toughest industry, semiconductor?
Yeah, this industry you have to love or hate because it's never dull, right? Either you have too much capacity or too little, you're chasing supply, or you have excess inventory or capacity. It's not for everybody. I know a lot of people like industries that go up or down, 1% a year and are more stable. This is really not as stable, but it's very dynamic. And I like that. I get bored very easily. I'm very impatient. So I just fell in the right industry for whatever reason.
So if you would pick an animal to describe the semiconductor industry, what would you say?
I would say it has to be a cheetah, right? Because like the best companies, right? They have to be agile, they have to be nimble. You want to be able to run fast and chase the demand. And you don't want to be too slow that the competition will eat you, or you will not be able to get the meal that you need for the day. So I would say that's the best animal to compare the industry.
Lovely. We will spend a lot of time talking about this cheetah today, trying to understand better. Yeah. So before we dive into today's topic, I would like to share some facts announced by the Semiconductor Industry Association to give everyone an idea the scope and the impact of the industry. Semiconductors were actually invented in the United States. Since the late 1990s, the US semiconductor industry has been the global leader with almost 50% annual market share. In 2021, global semiconductor industry sales totaled $555.9 billion US, the highest ever annual, and an increase of 26.2% compared to 2020. As chip companies ramped up production to address high demand aimed the global chip shortage, the industry shipped a record 1.15 trillion semiconductor units in 2021. The US semiconductor industry is second only to the US pharmaceutical and biotechnology industry in terms of the rate of R&D spending as a percent of sales. Americans' position has been challenged many times over the decades. It has always prevailed due to its amazing resilience and ability to run faster. that reminded me about cheetahs. Over the past 3 decades, the semiconductor industry has experienced rapid growth and delivered enormous economic impact. Chip performance and cost improvements made possible the evolution from mainframes to PC in the 1990s, the web and online services in the 2000s, and the smartphone revolution in the 2010s. As Francisco said earlier, more and more, almost every industry will rely on semiconductor moving forward. So Francisco, you started working at Infineon in March 1991. So that's almost 31 years ago. In comparison, what has changed and what remains the same in the semiconductor industry?
So what probably has changed is that the demand for the semiconductor devices in general has just continued to grow. And probably in the early 90s, it was mainly for, laptops, maybe some cars had some components, some mainframes and computers, but it was not as wide used as it is today. Right now, it's used pretty much everywhere. The growth of the industry has been tremendous. And then you have the 5G revolution in the mobile industry. So that requires a very large amount of semiconductors. With the pandemic, working from home, a lot of cars. The cars are mainly electronics these days. Then you have the medical devices, electric vehicles driving that growth. So I think the content and the demand has continued to grow. And probably one thing is that the semiconductor has a lot of up and down cycles. Pretty much every 5 to 8 years, you have a boom, and later on you have a bust. That the demand goes up, everybody builds fabs, then the demand goes down, and then you have empty fabs, and then you have excess supply. So in my lifetime, I've seen 4 or 5 big cycles like that. But this last cycle, this last shortage that impacted everybody hears about it in the news, the US government is getting involved. That is the perfect storm. We're talking to pretty much all the industry experts and the different companies. This is the largest gap we've seen in terms of supply and demand. It will fix itself over time, but this is the largest we've seen. It's kind of the perfect storm with all the components. Very dynamic, very challenging, the situation right now.
That's a lot of insight. Thanks for sharing that. We have a poll question on the screen I'm going to share with everyone here. So why do we face global semiconductor shortages? And it is a multiple choice question. Look at how our audience responded to it. Supply reduction, 10% the answer thinking that way, and demand increase, 30%, forecast mismanagement, 20%, capacity limitation, 25%, trade policy, 5%, force majeure event, 5%, and all above, 55%. It's a very interesting snapshot. We have audience share their perspective. More than 50% thinking that all above reasons caused today's semiconductor shortage. What about your perspective, Francisco?
Yeah, I think the all of the above answer is probably the correct one, because every component that is mentioned there had something to do, especially with pandemic force majeure events. There were energy shortages because of the winter. In Texas, there were increase in demand, in reduction in supply, trade policies, capacity limitations. So all of the above. That's why we're talking. This is the perfect storm, and that's why a lot of the companies in the semiconductor industry are enjoying record high prices in their stock price because everybody wants their components. So yeah, I would say it's all of the above.
So semiconductor manufacturing is an incredibly sophisticated and complex process. Could you help our audience to understand by describing the end-to-end semiconductor supply chain?
Yeah, I can briefly describe it. One of the challenges with the semiconductor industry is just the very long lead time to build one product, because you have to start from the wafer fabrication process that, depending on the technology and the complexity of the product, of the design, it can be anywhere from 2 months to 5 months time from start to finish. And this is done in wafer fabs, probably you've seen or heard clean rooms that cost hundreds of millions of dollars to build and maintain. And you need to wait 2 to 5 months just to get the wafer. And after the wafer processing, typically you go through some back-end or post-fab processing. So you need to do some, we call it wafer sort, where you test the wafers, or you need to put some bumps in it or dice it. Then you need to do assembly and test of the final module and the package that probably you've seen. There are modules that are already packaged. And then that's kind of the end product of the semiconductor companies. And then that will go eventually into cars, into phones, into laptops, whatever. That whole cycle can be anywhere from a minimum 3 months all the way to 6 to 7 months. And that is the challenge, that if I have a short-term need and I'm out of a component and I need it next week to run my automotive line, unless there's something in the pipeline, I'm not going to get it because I didn't place the PO on time, or there's no capacity, or whatever happened. So that is the challenge of this industry. The lead time for the semiconductor is just very, very long. So you really need to plan ahead. It's not like just placing a PO for regular items off the shelf.
Mm-hmm. Yeah, that sounds very complicated. The longer it takes to finish all of those processes, more surprises and uncertainty throughout the supply chain. And in addition to what you just described, we mentioned earlier about R&D investment from semiconductor industry. So you have an even longer cycle in terms of research and development, in terms of the design of the chipset before you even started the wafer stage.
Yeah, absolutely. I see design companies, they're probably thinking of products in 23 and 24. That you have to start the R&D, you have to start the design and working with the wafer fabs to make that happen. And then eventually goes into production. So yeah, it's very long development cycle. And I should say also, in most cases, a fairly short lifetime. Some of those designs only last a couple of years because everybody wants the latest and greatest phone or gadget or Wi-Fi router, whatever. So it keeps changing and you have to keep evolving with that. So that's also the challenge. Whatever you build, you have to get it right. It will last a couple of years and you have to start, with the next design that is coming just to keep up with the technology pace.
Could you also give us a sense in terms of the investment for the manufacturing process? Let's use a fab as an example. What type of investment are we talking about? How much time it takes to build one?
Yeah, even though the capacity crunch of the semiconductors started more than 2 years ago, it has not been solved yet. It's because it takes 2 to 3 years to build a fab from scratch. If you have no building or nothing, it takes just the planning, just to get the funding. It takes hundreds of millions of dollars, if not, close to $1 billion, depending on the technology. You need to make sure that a capacity is going to be utilized. So you need customers for that. And then just to build the clean room, the site, and the tools can take anywhere from 1 to 2 years to get some of the tools to make the wafers. So that's why, as we identified, the industry identified the shortage, it's going to take 2 to 3 years for that to balance itself. And new capacity is coming online, but not for every single technology. Some older technologies, people are not investing. And that will create a kind of an imbalance for probably a little bit longer time. Other ones, high-end nodes, or the latest technology, that's where most foundries are investing. So yeah, it's just time to develop that is very long. That's why it's a big challenge. Versus other industries that you can probably resolve capacity situations in 3 to 6 months.
In terms of end-to-end supply chain, there are different players, right? Each player, maybe the category of the company, contribute a different value. And a given example will be, there are companies doing everything, the design, the research development, the wafer fabrication, as well as the final device and testing, packaging, everything. An example I could think of like Intel. And could you tell us a different way that you could make a contribution and impact within the semiconductor industry in terms of their business model?
Yeah, so there are different business models. So you have players like Intel that design and they own fabs and everything. But also you have a lot of very successful fabless companies that just outsource all the foundry manufacturing. They just concentrate on the design of the component.
Could you give us an example of fabless?
Well, obviously Qualcomm is one of the largest. AMD, I believe, is also fabless. Marvell Technologies, fairly large company as well. So those are companies that have no fabs and just rely on their foundry partners to do that. And then you have the hybrid. There are a lot of companies that have wafer fabs, assembly, and in-house manufacturing for portions of the technology or the process, and they outsource other pieces to depending on the technology. So you have the whole spectrum, companies that do A to Z and companies that only do the design portion of the devices. All models are successful. There are very successful companies in all three models.
What is the current bottleneck in terms of ramping up for more supply to resolve the shortage problem?
Yeah, there was a report from the US government that publishes this public information. So they ask all the companies to kind of explain what's going on with the industry. No surprise, the wafer production is the main bottleneck. And that one is the one that I explained that it takes 2 to 3 years to build new wafer fabs or expand capacity in existing fabs. And that's the main bottleneck. There are a lot of activity to expand capacity as fast as you can. Also, the US government is doing a lot of promotion for moving more domestic production within the US and try to bring some of the manufacturing capabilities in-house. So you've probably heard the news. A lot of companies are investing in US fabs like TSMC, Global Foundries, and such, Intel as well. So yes, that is the main supply shortage right now. People ask me recently, hey, why I cannot get my car? I'm supposed to get a new car and I cannot get it. They say they don't have semiconductors. The automotive industry is very unique, right? They were famous for running a just-in-time model where you have zero inventory and the parts just come 1 or 2 days of inventory. Well, that model didn't work when you're short of supply and suddenly you cannot get parts for 9 months. So that's probably what you've seen in the news. They're missing probably a $1 component and they cannot ship a $50,000 car to the end customer. So they're gonna probably change their whole perspective on the amount of inventory to hold on certain components. They're gonna probably scratch the just-in-time concept for this type of components at least.
Yeah, that's a classic example about the downside of just-in-time. I wanted to zoom into capacity planning, which is today's topic. The semiconductor industry capex reached 152 billion US dollar in 2021. And prior to 2021, the industry had never spent more than 115 billion on annual capex. Do you think the trend will continue?
I think we'll continue definitely. I saw some forecasts that in 2022, which is we're already into this year, the spend is going to be greater than 150 billion. My guess is that we'll probably stay flat in 23 and 24, and then probably will continue to grow as the supply and demand will eventually balance out. Some people say it's going to be during the summer that it will balance. Some people think it's going to be until next year of 23, depending on the different variables impacting this supply-demand situation. But yeah, it has to go down. It cannot keep up at this rate of growth because then there will be excess capacity for sure.
So you have mentioned earlier about a cycle, right? 5 to 8 years. So you have lived through many ups and downs within the industry. Could you give us an example or share a story from your own experience that why is capacity planning essential and what are the challenges and what could you do to overcome those challenges?
Yeah, that's a good and tough question because there's no clear answer because every situation and every cycle is a little bit different. But in my experience, there was one particular case that we saw very strong demand signal from the customers. Back then I was working for a company that had fabs. We decided to expand internally the capacity. We spent tens of millions of dollars. And then we saw the forecast from the end customers start to go down. Month after month, when we received the customer forecast, started to go down and down. And by then, you already placed orders for tools. You're probably already building a new clean room, a new fab, in some cases breaking ground for new factories. And after we saw a big decline, there was some economic downturn at the time, then you have to put the brakes on all the tools and everything. So at the point that we had to stop some tools that were actually shipping, they were ready to be lifted and delivered, and we have to put the stop on some of those orders and delay for 6 months, 1 year. In many cases that tools are idle for 1 or 2 years because you just expand capacity based on a unvalidated customer forecast. So that's the key. I think what you will see now moving forward is that people are going to be more skeptical to just add capacity without having some some agreement with the customer. So it has to be more of a joint agreement that, okay, I will invest and I will add capacity, but at the same time, I need some guarantees that demand is going to come true. There are a lot of partnerships that have been announced, especially in the automotive industry. I saw in the news that Ford and GM have signed partnerships with a lot of semiconductor companies just to secure supply for the next 5-10 years. The cars last a lot longer and the cycles are longer, so they can probably easily justify longer agreements. So yeah, that's one of the key lessons learned, that do not expand capacity just on a PowerPoint slide from a customer telling you that they're going to grow 50% a year for the next 5 years. It's very risky without any agreement.
Yeah, it's very interesting that many people got to know semiconductor shortages because of the automobile industry, right? Because they couldn't get a car and a lot of factory has to stop because of shortage of the component. But not many people would know that automobile is only taking 11.4% of the demand drivers of semiconductors. That means almost 90% semiconductors are going to other industry. Now we learned about it just in time, and there are the classic best practice within the industry also have its downside with a shortage crisis like right now. So Francisco, when we're facing unprecedented shortages and growing uncertainties, what learnings could we apply to determine the possible strategy between just in time and just in case?
Yeah, I think a lot of companies are rethinking their strategies. One other trend that came in that report from the US government is that the overall semiconductor inventory went down from 40 days on average to 5 days. And 5 days is nothing. That means there's any delay, even on freight. Something happens at the Long Beach port, you won't get your components, right? So I think everybody's rethinking their inventory strategy, and I believe most companies are willing to invest in a larger inventory just as a buffer to prevent the ups and downs of supply and demand. So we'll see an inventory correction to the increase in inventory in the companies in general. On top of that, you will probably see a lot of companies just engaging with their suppliers to really have a more frank discussion about the forecast and be more transparent about the demand. What is the real demand and what is the inventory buffer that you want to build, so we can make sure that we're meeting your minimum needs. So there's got to be more connection between the suppliers and customers and sharing that data across the supply chain, not only the end customer to the manufacturer or whoever is delivering the end product, but 2-3 levels down the road to make sure that everybody understands the demand trends. And I guess the feedback, just quick feedback, whenever you see a demand adjustment or an inventory adjustment, get in touch with your supplier, talk about it, get in touch with your customers. So it's both ways. You have to look up and down in the value stream to really make sure that you're passing the information as real time as possible. So you will see timing of communication being faster, the cycles of learning. In the past, many customers only share quarterly forecasts, or most people do these days monthly. I think you have to move to weekly or even real time. As things change, you have to communicate with your suppliers and customers. That feedback loop is really critical to make sure that you can react in the best possible way.
I have 2 questions. The first one is, since the capacity is finite, right, it's fixed based on the investment, and it takes very long time to build those capacity, a few years. But in the meanwhile, the data clearly showed the industry has shipped a record high number of parts. So what exactly is the industry doing in the short term when capacity increase is not an option? And what about in the midterm, let's say within the next year or 2? And then what about the long term?
Yeah, when the industry saw the shortage 2 years ago, some companies started increasing capacity. And because of the lead time to increase capacity, we haven't seen some of that capacity yet. We're starting to see some of the factories coming online in 22. We will see more in 23 and 24. So that capacity is coming, and that is in a way resolving the situation. On the demand side, there's also kind of panic buying, right? Like the toilet paper. Everybody goes and buys extra just to be safe because they heard there's a shortage. So I think there was a lot of double booking by customers, and you just order more than needed just to have buffer. And now if they couldn't get it, then they're probably canceling POs right now, or maybe they have too much toilet paper and now they're not going now to the store to buy it for the next 6 months. We're going to see that inventory correction that is going to level load the demand. So I think between those 2 things, plus There's clearly an allocation. So every company is making decisions on which industries to support, what partnerships you have. You probably won't make everybody happy, but you're trying to keep everybody afloat and alive, at least during this year. And in the prior years, that was clearly an allocation decision, who to support, how much to support. I believe it'll balance itself in the next 12 to 18 months at the max.
We talked about design capacity earlier when those fabs were being designed. What is the target for design capacity utilization?
Every company is different. In general, I would say 80% plus minus 5% is kind of ideal situation, that it gives you some flexibility to recover. Also, it gives you probably the best financial answer. Again, depending on the technology and the fab and the investment, companies will target more or less, but anywhere between 7 and 80% is a very good number financially. When you drop below that or even below 50%, you start losing money at a very fast pace. So that's why companies are very careful when they're going to invest, that amount of money. And then when demand is higher, if you try to run at above 90%, you will probably make commitments that you will miss because you're committing based on perfect execution, and any hiccup, you will miss commitments to customers and they will be very upset and probably visiting your factories. So it's a fine balance between what utilization to target and what commit level to use.
I was told by many friends within the semiconductor industry that they have worked so hard in the last 2 years trying to solving the critical shortages. And the latest data that I saw, utilization is over 95%. Everybody is really doing their very best.
Yes, everybody trying to get as much output as possible to help our customers. And some companies are making commitments and then they're missing it. We see that across the industry right now. But everybody's trying hard because it's a great opportunity. Plus, there's real demand that you want to fulfill.
Do you think a situation like this, the entire industry working tirelessly all together, does that help to build a relationship? Is the relationship within the industry strengthened through a crisis like this?
Definitely. CEOs of every company talking to CEOs of every supplier, and down the line, CEOs of designers talking to CEOs of foundries and assembly and test houses. A lot of partnerships being built. Everybody's getting to know each other. I think it's going to be for the benefit of the industry, a good understanding of the capacity and the roadmaps for every company and customer you have. That will help you plan better in the future. I'm definitely seeing that.
What do you think the government's role are when it comes to solving the shortages, helping enable the future innovation for semiconductor industry?
Yeah, you see different trends. So for example, China is putting a lot of investment into domestic production. They don't want to depend on foreign companies, so they have put billions of dollars into building new fabs and expanding their own manufacturing footprint. The US government is doing the same. The report that I read, they're putting $52 billion to enhance the domestic production. And they're talking to all the big players to make sure that there are investments within the US to expand the capacity. That way they don't depend on geopolitical situations in the future. That is happening. I think they probably have to do more into bringing not only the wafer fab manufacturing, but also the assembly and test in-house, or at least within America. So if you're doing wafer fab in the US or even in Mexico or Canada, you can do assembly and test within the region and shorten the cycle time and less dependence on the geopolitical issues around the globe. We're seeing that trend already. I think the governments can definitely either money for the companies to invest or provide incentives for companies to invest domestically.
We know 2 bills are being reviewed right now. One is the CHIPS for America Act, which is helping funding the semiconductor manufacturing and research. The other one is the FABS Act, which is offering tax credit. And how critical are those in terms of the global competitiveness for the US semiconductor industry?
Those investments and acts, I think, are going to help. But realistically, a large portion of the wafer fabrication is already coming from Asia, mainly Taiwan. And China is also a large producer of that. So I think those investments will help, but they're probably, it's just the beginning. I think we need to invest a lot more domestically in the higher end technology, especially just to keep up with the pace and have secure supply. Because a lot of these devices are not only for basic gadgets or cell phones or Wi-Fi, but it's security concerns, and they're also critical for medical devices, for supporting vital industries in the countries, right? So I think everybody's seeing the semiconductor industry with different eyes since this pandemic and this shortage happened.
It's a perfect time for government and industry work together in partnership. We need more chipsets. Einstein said, any intelligent fool can make things bigger and more complex. And it takes a touch of genius and a lot of courage to move in the opposite direction. As a tradition of our program, I hope to build an intellectual bridge between the current and future generations. So Francisco, how would you paint a picture for capacity planning by giving it a new perspective?
So to put it in simple terms, you're gonna take a shower. The water heater is far away from your bathroom. You may start by overreacting and putting everything on hot. And then you see it's too hot and then you put it to cold, and it takes probably a good minute or two, and then it's too cold. And it takes a while to adjust, right? So thinking of that as capacity, if the feedback to tell you when it's hot or cold is too long, you will probably over adjust. You will put too much hot water, let's say increasing capacity, or you put cold water, you will stop the brakes too soon. And that will lead you to make a lot of mistakes and probably corrections. You might get burned, or it's going to take longer to take a shower. However, if the feedback is immediate, then you don't need to over adjust. So I would say that that's a good analogy to how to improve the capacity planning portion. Is just get faster feedback from your supplier base, from your customer base, and work together to really understand what is the true demand and the true trends, and avoid over adjusting or overreacting. Now, that's probably one easy way to put it for the audience.
Yeah, that's a great analogy. Very easy to understand. I also prepared one. Here you go. Supply chain network is similar to transportation systems, both primarily governed and determined by the laws of human behavior. Traffic evolves because of decisions made by people move from one location to another. Supply chain flows because of decisions made by business to transform economic value from upstream to downstream. On the one hand, the uncertainties of human behavior made capacity planning an art form. On the other hand, certainties of finite investment and physical limitations of people, time, speed, and cost formulate the science. Like air traffic controllers, capacity planning prevents collisions, organizes and expedites system flow, and provides information to optimize the supply chain network. We also have a poll with the audience here, and I would love to share this result. The question is capacity planning more of a science, data-driven, or art and intuition? And it's a single choice question. So there are three answers: mostly art, mostly science, and 50-50 split between art and science. We got 56% thinking it's between art and science, and then about 38% mostly science and 6% mostly art. What do you think about the perspective of the audience, Francisco?
You know, I agree with the audience. I think it's a mix of art and science, because you can do math and you can say exactly, okay, this is how much capacity I need, but in the end, it's inputs coming from sales people and demand signals that may be off, customer bias. So I think it's a little bit of both. You need good science to understand the overall market and, you know, the opportunity, but it's also a lot of art and relationship building as well.
That's make it very challenging, but yet fun. So your dad is probably right. You're in the right industry.
Yeah, it's keeping me definitely busy. Yeah.
Okay, we also have some questions from the audience. What is your sense of where we are with Moore's Law and the impact of its softening?
So the Moore's Law came from Intel. So yes, I think it's not going at the same pace it used to be as far as the technology and the evolution of that. But I think the technology, I'm just impressed by the speed of the changes and the willing to invest in the higher nodes, as we call it, in the wafer fab. Just everything getting smaller and better and faster. I think that will continue. You know, the designs and the tools to design the chips and to fabricate the wafers, the tools keep improving. And I think we'll continue to see smaller and better gadgets and devices that will fuel the growth for technology. I don't know exactly how long it'll last, but so far it's keeping up with the pace.
Now government is playing an active role in terms of helping the industry. The industry has been working as hard as you could, as smart as you could. And obviously we are building more capacity and increasing the supply for semiconductor worldwide, as well as domestically in the US. So what do you say about talent pipeline? Do we have enough talent in the US for semiconductor industry? And what type of talent are you looking for?
Okay, I will say that there's still a shortage of talent in the US. Most companies are struggling to hire not only supply chain talent, but also people in the electronics engineering field. And as more fabs move domestic, I think the schools have to promote more people going to engineering degrees. In supply chain, I don't see in the US the same amount of people taking industrial engineering or supply chain as compared to, for example, my hometown in Mexico, where industrial engineering is very popular. The company that I used to work for had thousands of industrial engineers available for supply chain. So very good supply chain talent there. I struggled to make hires in the US in my prior 2 or 3 companies. So I think there's still a shortage of talent in certain areas, the ones that I can speak to. And yes, I think we have to definitely promote that within schools. And it's a very rewarding job. I mean, it's very well paid for the most part. So every opportunity, I encourage my friends' kids to study engineering degrees and try to do that with my kids. I convinced one, I couldn't convince the other one, but 50-50 at least.
In terms of demand planner specifically, what would be the ideal profile for a candidate from university? What do you like them to study in terms of major? What kind of experience or talent that you think would be super helpful?
So demand planner, you can get a lot of people with either economics or marketing degrees. Those are good because you have to understand the end markets. But also, if you're going to work in a semiconductor industry or a high-tech, company, you can achieve that with an engineering degree and an MBA. That's what I would recommend, because you have a little bit of technical background, but then you also have some of the business experience to allow you to really excel at the demand planning role. So that would be my recommendation.
You mentioned earlier that you advise your kids to study engineering. In terms of the semiconductor industry engineer is definitely one of the major that you mentioned. Is there any other like data science or any other major would be helpful?
Well, electrical engineering, mechanical engineering, all those are going to be needed. And there's still, I would say, a shortage in general. You mentioned computer science. It's not only about the hardware or the actual silicon and the semiconductor, but a lot of the performance and delivery of the final product is on software. So software engineers, computer science, all of that is in high demand. I would definitely recommend to concentrate on that as well. You can have the best device, but in the end, you need software to run it. You need software to monitor it, artificial intelligence, and just taking advantage of the power of the computers these days. If you have both, I think it's very powerful. You will definitely be in high end, and you can make a lot of money just as soon as you finish college. There will be people waiting to hire you.
From supply chain standpoint, what's the best partnership that, in your opinion, in terms of within North America, between US and Mexico, when it comes to semiconductor industry, now that we need more capacity?
Talking specific about the partnership between US and Mexico, I think Mexico is an excellent option for assembly and test. However, to build wafer fabs, I believe there's not a single wafer fab in Mexico yet. There's not enough infrastructure or government incentives to really push for that direction. There's definitely engineering talent and manufacturing capability, but I think the government is just not pushing in that direction, or if they tried, it's not good enough. You need good water supply, good energy supply, and good incentives. So that's probably where Mexico is falling short. But the other industries, there are a lot of good partnerships in automotive and in manufacturing, electronics and assembly that are working very good. In medical industry is another great example. They do a lot of outsource to Mexico in particular and Canada. And very good partnerships between North America trade agreements. So yeah, the thing is just more tax incentives to bring wafer fabs to Mexico.
Wonderful. Francisco, I really appreciate your partnership covering the art and science of capacity planning. I hope you enjoyed this conversation.
Thank you. It was a great time. And thanks for the audience that stayed through the end. Thank you.
We also appreciate great questions from a high quality and a high energy audience. I hope everyone learned a few things from each other, and I look forward to seeing you again in our next episode.
Thanks for listening to Oceanside Chat. We hope you enjoyed this conversation. If you liked it, Please share this podcast and stay tuned for our next episode. We'll see you later.